I get you tonight? I've been told I'm the best bartender from Timbuktu to Cortland. So please, step up to the bar and I'll serve you what is likely to be the best beverage you've ever had. And your last.
Mike Comtech coming to you here with another video. I made a test jig for my bigger animatronics for good reason, so I can get into all the circuits and not be work around congested areas and that kind of thing. If it's sitting right here in front of you on a bench, then you can really do a lot more, because there's a lot of outputs I want to look at on the controller. And one of them I was doing was with the IR input of this is Dean the Deathologist, and he's got an infrared input, of course, and that's right here. So I was looking at the voltage here. I wanted to find the positive, I wanted to find the negative, and very importantly, I wanted to find the signal line. So I am tapped on these two, the first two. So the red one is positive out. I think I measured that at about 3.8 volts DC. And then the yellow is negative. And then the orange is the signal line. That's the signal one, the orange one. So if you take that orange line high from this one, it will activate Dean. So that's because there's a lot of different controllers I wanted to input triggers I wanted to try. But having this jig like this, it's sitting right here on the bench, on my big bench, and I can get to all the circuits, like I said, and get to everything without having to mess with the larger body on that. So Dean has two motors. He has a motor here that drives the head back and forth. So then I made a linkage from the original and ran a really sophisticated line up here. It's called a coat hanger, all the way up to here, and I made a little simple pivot on some washers and a standoff. I had to experiment a little bit with how far I wanted to go, the distance here on the standoff. And then I had some corner reinforcement brackets that I had laying around here. So I extended one of these and then made an L here. So when this moves up and down, then it triggers this other horizontal piece of coat hanger, another sophisticated piece. And then I made a circle, and then so that way when I put a hose clamp on here, it had a lot of area to grab. So then this horizontal piece can't move or float around. So when the head moves back and forth. And so then the travel distance, let me undo the pin here. I can show you how easy it moves if I can ever get the pin off. My fingers, there we go. Get it off here. And then, I thought I had it. That little bitty pin is so small. Here we got to get it up in the right position. But I wanted to show you the travel here on the output. There we go. Gee whiz. So if I take this now and move this up and down, you can see it moves super easy. I mean, it's not even under any restriction whatsoever. And so that motor has no problem running it. In the actual Dean itself, they run of course, that same motor. This is Dean's motor, but they run it horizontally up in the shoulder area, and it's just a straight shot right into another pivot point that goes vertical, and then it runs up to the two pins that this slides into, and then that's how they get the animation out of it. So it's actually, it's the same thing. It's just I'm doing it a little bit differently here than they are. But just wanted to show you this little jig here. And like I say, it makes it so much easier to move around and mess with it. This is Dean's control box. This is the actual control box from Dean, and so it has a multifunction switch. You know, it runs right now and it's in IR mode, sensor mode. And then if I flip that to the center, then it's you can use the try me input right here. And if you flip it to the other mode, which is continuous play, it'll just keep continuing to go through every one of his routines. But right now I've got one of the other timer circuits hooked up here.
Hello, good evening.
And then I'll shut him off for now. I've got it set to 5 minutes, 300 seconds, so it kicks up the, it throws that input high at 5 minutes through these outputs here. It throws that and then deactivates. It was basically, I could have done it just all sitting here on the bench, but it was kind of fun to go ahead and just make the head animate too while I was at it. Since it was here, might as well just, you know, you had all the functionality. Let's go ahead and see if we can animate the head real easy, you know. But that way I can mock all this up and then I can move it to the actual frame of Dean, and then don't have to mess with all that. And then the bottle is completely, it's all kind of animated here. They've got LEDs in the down tube where it looks like he's pouring the poison elixir into there's a glass there, it goes under at the end of this. So if I turn that on.
Hello, good evening. What may I get you?
So it runs a sequence, and it's an RGB LED strip. So it has positive and negative and then a data input. And all the sequencing is happening here at the control box. So you just can't supply this strip with power. Some people were talking about they would like to power up Dean and have it just run the lights by itself. Well, you could do that, but these would just be on all the time unless you want to really actually drive this with an RGB controller and then tell each LED when to turn off and on and on and off. That's the beauty about RGB. You can program each surface mount LED in there, what to do, what color to be, and that kind of thing. But you could do it. I mean, it can be done. It's just you just have to take the time to do it and then figure out what you want to do. And as far as the circuit, to drive that LED array. Or you could put, these are basically, if I pull this down here, you can see this is just it's an RGB strip. And there's the surface mount LEDs there. And that's how that is, just up inside this tube, like that. And it's pretty sharp. The audio is very, very clear on it. The speaker is here in the back. You got a volume control on it. And then I've got this output right here. This red is driving the motor in the head. This is powering the LEDs, the lights in the eyes. And then you've got this lead right here, which is actually driving the up and down motor for the head movement, the lateral head movement. Then I put on a couple of spring-loaded clips here where I push these down and it opens up a slot, and you can put, so there's the 5 volts or the 5.5 or 5.9. Actually, the whole thing's supposed to run on 5.9. I run it at about 5.5 because of the relay right now. If I was going to do something like this and run that relay, I would feel more, this runs at 5, and I would feel more comfortable if I just use a buck converter, and it would take the 5.9, knock it down to a safe 5 for this circuit if you want to ever incorporate something like this in here. And I found out there was 2 different versions of this timer, because I ordered some more timers and I didn't really see it until I looked at the model number. I know it's upside down, but this is, let me see if I can flip this around for you a little bit here without breaking anything off. This one happens to be an HCW M421. And if you notice underneath here, for you guys that are familiar with this timer, there on the other timers that I used, and I have on the other projects, there's 2 pads to allow you to input 5 volts. Now this one has pads to input 6 to 30 volts, and then you got your ground, and you got your trigger input, and you got your ground trigger. And then there's 2 pads you can solder across here that actually makes this ground go to this ground, so then it fires up that opto isolator so you can actually run a trigger voltage in here. But this one here does not have the 5-volt pads for input. It has a micro USB port like the other one. Now the other one was more versatile. It had a micro USB port, had the pads for a direct 5 in, and then it also had these, you know, for 30 volts. So I said, well, shoot, you know, I can make this work. So I probed around on the board. This chip, not a chip, but this transistor right here is a voltage regulator transistor, chip actually, I guess I could call it that. I found the pin output. So this was outputting 5 volts right here where I soldered the red wire on. So if I get this around here, you can see it. I soldered a red wire right on the output pin of the voltage regulator, and then went ahead and just picked up ground right off of the metal part of the USB-C connector, or the micro USB connector. Picked up a ground connection there because I have this running the routine, the program mode 3.2, so it's counts, you know, 5 minutes, closes the relay for half a second, just enough to fire the IR high, and then Dean turns on. But so there's one way to skin the cat, isn't there? So you find it, I found that, so I just inputted it there. So now this runs on 5 volts this way. But if you did want to run it the conventional way, then it goes back through the regulator. And if you want to run higher voltage, anywhere from 6 to 30. I found out that 6 volts pulls the relay in, but it's kind of weak. This thing really ultimately, if you're going to use these DC inputs here, actually ultimately runs better at around 9 volts and higher, up to 30. Just don't go over 30 volts, because that voltage regulator right here at the top where I tapped in is what's regulating this input voltage to an always constant 5 for the rest of that board. But right now, I'm just directly feeding 5 volts into here, or 5.5. It does run okay at 5.9. I didn't have any thermal problems. I didn't see any thermal issues at running it at 5.5. The LEDs were just a little bit brighter, but not much. It's not to the point to where they would, you know, prematurely fail, I would think. But right now I just have that on there just to test the input and to kind of exercise the animation part of it, you know, over here. So that's how that works. Pretty neat. It didn't take too long. Put that tube back. Didn't take too long. Let me fire him up real quick here. I'll just hit the try me button, and then I will show you how it works here. Go ahead and reset. Let's let it kick up on its own.
Hello, good evening. What may I get you tonight?
So that's the simple little pivot
I'm the best bartender from
that rolls the head back and forth.
So please, step up to the bar and I'll serve you what is likely to be the best beverage you've ever had. And your last.
That's how it works. So it's pretty neat. I enjoy it. It's a lot of fun to do this. And sometimes you run into a challenge, but that's what makes it interesting. The challenge keeps you pushing forward. So mounted that, you know, mounted the motor here down, mounted the control box down the same way, put, you know, little 45 brackets there. So this is a neat little breakout box, you could call it that too, you know, that way you can see everything, get to everything. So anyway, I appreciate it, guys, for watching my videos as usual. So we will talk to everyone later.